Hi, my name's Jake and I'm going to do a little tutorial on how to do some exploit dev or vuln dev or whatever you want to call it. This is going to be on finding finding the vulnerability and then exploiting it. For this program, it's somewhat complicated, so uh, if you want to get started in ZOS exploit dev, I highly recommend starting on this. It gives you there's a Docker image with a MVS 3.8J, which is public domain, so anyone can just run it. And all the exploit techniques that are in this tutorial they work just as fine on ZOS. So run this Docker, go through this slide deck, and you'll be up to knowledge to be able to understand this exploit better. So I'll just compile this program, but we are compiling it with AC1 in an APF authorized library, so if there was an exploit in this, then you could use this to escalate your privileges. It's fairly simple. It reads 4,000 bytes from the standard input into this buffer, then string copies that into a 10-byte buffer, so we can obviously see there's going to be a buffer overflow, and then also copies this text here into the pointer pointed to by this string pointer, so this is what's going to be overflown and what's going to cause the error, and then print it out so we know what it's actually doing. So let's compile this program, and for the little test run, we've just put test and sys in. Okay, so we compiled it. And all this junk, and then it just goes good day test and then pogchamp. So let's cause the error. So it's just a JCL to run the program. F gets copy in the dsn demo.apf lib, and for the sysin we're going to pass it demo.fb32760. This is a PDSE of this format, and this is just a member with 30,000 A's. So if we have a look at that, yep. So we run this program, and we get a SOC4, or in Linux terms, you might think of this as a seg fault. But the reason why this has happened is that we can see that in register 1 we have C1, 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 and let's have a look at this instruction that we're appending on. So I have a rec script called decodei, and if we have a look at this, I basically wrote almost none of this. I took someone else's GPL version 3 code and made it so instead of decoding an entire program, it just decodes one instruction, so decode I. And so we give it this, and we see that it was MVST R1 R2. So what this is move string from the data stored at register 2 to the data stored at register 1, and this is also it's kind of interesting because how ZOS or Zarch has a very complicated instruction set, and so string copy gets compiled down to this one instruction, and if we run AmberList, which will tell us the symbols used, we can see that there is no string copy in the symbols, so don't let that confuse you. Okay, close the. So we can see that we've overflown the target address, and the source address is this address, and it points to PogChamp, and then it ends in 00. So this is all we're able to move into an address. But let's see where. So we passed it 30,000 A's. Let's see what actually where those A's are being grabbed from. And so let's just change this to pattern. And pattern is a De Bruijn string, which is one big record. I think there's like 20,000. And I also did not write this. This is a gist. I'll post the link as well. And actually, Gira wrote this, and it just, you give it a length, and it will just spit out a big long list of De Bruijn string. Okay, so yep. Let's run this. Oh, just so you're aware, this POM does nothing for this program. It's just, I always just have this here for whatever's sake. Okay, another SOC4, just as we expected. And however, in register 1, we can see C181 F5 C1. So if we have a look at pattern, that is there, C181 F5 C1. So this is where it's grabbing the register 1, or where it's overflowing into that that string pointer. So let's just change this to deadbeef, so we're 100%. Let's make a new file. Okay. Let's call it sysint1. Okay. And so we're in the let's put sysint1 in, make sure we're in binary mode, and we're in this PDSE. So let's run it with sysint1. And another SOC4, as we expected. And we can now see in register 1 we've got deadbeef. So when we're trying to exploit ZOS binaries, because we're in where's our PSW? Yeah, because we're in key 8, we can't muck with any of the system stuff because we need to be key 0 or whatever key to access that. But what we can do is we can change our working storage, and specifically the ones that I always try and aim for, because there's lots of like return pointers and stuff like that, is the DSA, and the current DSA is located at register 13. So that would be this address. Nope. This address. You can see it also there. And what we want to do is just change deadbeef to register 13 plus 4. The reason why we want plus 4 is because this is the previous DSA pointer. There isn't actually anything at specifically here. So let's just do that now. Okay, copy. Okay. 1F248.4C. So sysint2. Yep. Okay. Okay, and append equals, this is going to be a U4083 error, which is a language environment error. The only thing about this is that these errors are basically not very helpful. So now what we need to do is add some language environment run variables, and we want to just dump stuff instead of doing the whatever it does. I don't really, not entirely certain how language environment works like fundamentally, but this is good enough. So let's run this again, and a sock force. Now we actually get to see what actually caused this error. Okay, so if we look at register 13, we can see that we've balked it. We've put D7, D6, C7, C3, and if you have a look at PogChamp, that's what PogChamp is. So we've put PogC into register 13, and now it's trying to, we can see right here, load register 14 from 12 bytes from register 13, which that's yeah, we're not going to have we don't have access to this. This isn't a real address. So instead of overriding the entirety of register 13, let's just override the last 2 bytes. One thing to note is that we can only really move these characters, so if we want to edit things, it's going to be difficult for us to edit the entirety of an address, because all we have is the ability to move this. But yeah, let's move the last 2 bytes. So, well, actually, let's move the. Yeah, let's go. So, 4D. And we put this. Oh, and a sock1. So, we've now just edited the last 2 of these. An important thing is that O in PogChamp D6 is even, which makes it a lot better for keeping things aligned. But it's grabbed register 14 from 12 bytes after this, but we didn't have control of that, and so now it's just 00000, which doesn't really help us. At this point, we'd be able to tell the client, the vendor, the whoever we're finding this vulnerability on, that we found a vulnerability, we've changed the PSW, we've changed the DSA pointer, we know we have something here. But they might say, you're in key 8, you're in problem state, you're in non-soup state. I don't care, you haven't done anything. But so we'll continue on and actually get this vulnerability working. So this is the thing which is going to help us, is that we need to have our data at the first 4 bytes of what was the DSA, D7, D6, and with the memory that we have, we're never going to get there. So if we look at let's look at our actual where our actual data is being stored. There we go. Okay, yeah. So D7, D6, but our data only goes up to 9240, and remember that we have a hard limit of 4,000 bytes. We can't send any more than that, so we can never get to, we'll never be able to use this with these memory locations to get an exploit. Or we might be able to, but it won't be at this exact location, and I did try and I couldn't find another place where we could change something which would allow this to just work. If anyone could, if that's a challenge for anyone who wants to try and do it without this method, without the method I'm going to be showing you, But yeah, one thing you can do is you can use cops to pass some stack information. And so basically this is some random information of how it like allocates memory. One thing that I highly recommend doing is always put it below for these exploits, because when you put it below, the data and like the instructions are a little bit closer together, and it just makes everything a lot easier. And then just change these numbers, and see what happens. Importantly, we want to be appending at the MVST. So let's put it back to sysin1 with the, I think that was with dead beef. Yep. So let's run this again. SOC4, as we wanted. Okay, and let's scroll down to where our data is. And it is at so 18E80, and we'll see that we never get to 1D, which is what we need it to be at 1D, which it isn't. So just keep changing the number. Maybe this works. I hope if anyone is watching this, they're excited for me just changing the numbers. Oh, nope. Just gotta keep changing them. And maybe I may have found one beforehand, and because it's probably better for me to just use one that I know that works instead of just doing this for the next 20 minutes or longer. Okay. So we run this, and we can see that its number's getting close to where we need. And so we needed D7, D6, I think was the... We go to register 2 again. It's D7, yeah, okay, yeah, D7, D6. Just go back to... Yep, D7, D6. Okay, yeah, just double checking. Okay, now let's open up another... Okay. So where we want to now target is here. So important thing we need to do is that because we're doing MVST on these, we can never do a 0 byte, or else we will just cause the program to not work, because 00 is how it's the null byte. So we do 80 because we're in 31-bit mode, so 80 and 00 is the same thing. Then 1D, then nope, 01, D0, and then 9C. That's the start of the now if we run this and actually change this, Why not? Okay, yep, so we've now overridden this. But let's add 2 to this now. So 9e. Put that. And a sock6, so that's good because it means that our PSW is unaligned, and we can see that our PSW has been changed to C3, 85, F3, C3. So let's look for that in our sysin3. C3, 85, F3, C3, and it is here. Let's change this to, actually let's make a new, damn it, okay, where did I, let's change this to Cafe Babe. Okay, let's put that. And yep, we can see that our PSW has changed to Cafe Babe, so it's a good sign. Let's just actually change it to where we want to change it to. So that is our, I think this is probably a decent enough address to go to. Okay. D1 60. SOC1. This means that we're trying to execute code that doesn't exist, and yep, we can now see exactly that we've done this. So now the next thing to do is actually run some code. Okay, so what's the yeah, so okay. F7, just cool. It's this code here. So let's just do something that. So 18 is load register. So let's just put everything. Let's load register 3 into 0, 1, and 2. So 1, 3, 18, 2, 4, 18. Cool. I put that. Look 7. Yeah, here we go. We can see that we've now put register 3 into 1, 2, and 4. So that shows that we've actually run some code. But the next objective is to actually we want to escalate our privileges, and to do that we want to use here's a little program that yeah. Actually this won't, yeah. And can't remember where I actually put the actual program because as I said, this is going to be a string, so you're going to need to not use certain bytes. So I will do that another time. Hopefully anyone who's watched it found it interesting, and if you really do want to like get into this, highly recommend going to this training LPAR. Yeah, because at the moment I feel like there's only like 10 people who would actually gain any value probably from listening to this. So yeah, I've got a yeah. Alright, well, thanks for listening if you listened. Thanks if you didn't. Cool. Bye.